Hello everyone. In this video, we will derive the formula for finding the sum of first n terms of a geometric progression. A geometric progression, GP, is a series of numbers starting with the first number as a and subsequently obtaining each number by multiplying the preceding number by a constant ratio r. So here our GP is a, AR, AR square, AR cubed, and so on up to the nth term a r raised to n minus 1. Our objective is to determine the sum of all these n terms. To achieve this, we multiply both sides of the equation by constant ratio r. This gives r times the sum of n terms on the left side, and on the right side each term is raised to the power of r by 1. We obtain AR plus AR square plus AR cube plus AR raised to 4 and so on up to the last term as AR raised to n. Next, we subtract equation 1 from equation 2. Let us denote the first equation as 1 and the subsequent equation as 2. Observing the terms on the right side, we notice that AR and AR gets cancelled out. Similarly, AR squared, AR cubed also get cancelled out, and so on. The last term to get cancelled out are AR raised to n minus 1. So, we are left with A minus AR raised to n. Simplifying, we have Sn common and 1 minus r in the brackets on the left hand side and a common and 1 minus r raised to n on the right hand side. Our primary objective was to find the sum Sn. Therefore, we make Sn the subject of the equation, resulting in the formula for finding the sum of the first n terms of a geometric progression. The formula is Sn equals to a times 1 minus r raised to n divided by 1 minus r. Now, if we multiply both the numerator and the denominator by negative 1, we obtain another form of the same formula as Sn equals to a times r raised to n minus 1 divided by r minus 1. Generally, the first form of the formula is used when the constant ratio r is lesser than 1, while the second form of the formula is used when the constant ratio r is greater than 1. I trust this video has aided your understanding of the formula for the sum of the first n terms of a geometric progression. Thank you for watching and learning.